Algorithm, geometry, gram scan. Are you ready to meet our team?
Assalamualaikum, I am Nur Alia binti Nur Hisham. My metric number is DI220188.
Assalamualaikum, my name is Siti Asyatun Insan binti Muhammad Syukur. My ID number is DI220096.
Assalamualaikum and hi, my name is Nur Izzati binti Saimi. My metric number is DI220079.
Hi, Assalamualaikum. My name is Ainul Nabila binti Ibi Rahman and my matrix number DI220065.
Assalamualaikum warahmatullahi wabarakatuh and hi everyone. My name is Asamia binti Nuhar Mizi. My matrix number is DI220023.
Nice to meet you. What is gram scan?
What is Graham scan? So, introduction of Graham scan. Graham scan is a fast algorithm for finding the convex hull of point in a plane. By sorting point based on the polar angle, it effectively constructs a minimal convex polygon, widely used in a computational geometry and related field. It's simple but assumes no collinear points. Users need to address these limitations with pre-processing when necessary. Despite this, its span and simplicity make it popular choice for convex hull computations.
Background of study.
So next for background of study for Graham scan. So firstly, Graham scan was invented in 1972 by the original algorithm. It was founded in collaboration with Ronald Graham. A method used to find convex body for a set of points in a plane with a time complexity of O and log n. And next, an algorithm that searches for the lowest point in a group of points. And next, algorithm can be run in various ways. One of which is the start is used to detect and remove the concave that is in the boundary. And next, example like the lowest point in the y-coordinate is found, and if the lowest point exists in more than one place in the set, the point with the smaller s value is chosen. Actually, finding the lowest point in accumulation of points is how the Graham scan operates. The remaining points are subsequently organized according to their polar angle with regard to the lowest point. After that, the algorithm keeps a stack of points that are currently on the convex hull by iterating through the sorted point. A point is removed from the stack if it causes the existing stack to become non-convex. When every single point on the convex hull is present in the stack, the whole process brings to a completion. And next, Graham scan can be used in several situations, such as cutting polygon on convex body and so on. And lastly, Graham scan also a method that can be utilized for calculating a convex body against a point in a larger dimension.
Review of related literature.
Assalamualaikum and hi. Today I will present to you review of related literature about convex hull and Graham scan and the workflow of Graham scan. Convex hull method. First, estimate and identify uppermost point through addition points. Second, coordinate of point on the convex hull are presented as x1, y1. Third, visualize in this figure 1 on coordinates point. Graham scan algorithm. First, supports convex hull implementation efficiently. Second, release on sorting points regularly along a chosen point P. Third, create a simple polygon from the sorted point from this figure 2. Continue from the previous slide of Graham scan. 4. Time complexity O n log n for sorting plus O n for convex hull computation. 5. Widely used in information visualization, such as in image processing. 6. Visualize workflow shown in this figure 3 with P1 as the starting point. So for the Graham scan workflow, first start at a a designated point P1 in figure 3. Second, detects the relation between two lines from the same point. Third, determines turn left counterclockwise or turn right clockwise pattern. Fourth, remove point forming a turn left pattern if no turn right patterns follows. 5. Illustrate in figure 3 with P1, P2 forming a turn right pattern leaving P4. Okay, that's all from me. Thank you and have a good day. Bye.
Methodology.
This study uses the O n log n algorithm, or also known as the Big O notation. So the Big O notation is an efficient and scalable solution for problem solving. The notation shows that as the size of the input grows, the algorithm's runtime will also grow. This notation is implied when algorithms like Graham-Scan for convex Hull computation achieve its efficiency. So, the methodology used in this study is the iterative model, because iterative model has a choice, and the other reason is it can turn to another point if a certain condition is met. In this context of the study, it allows a choice whether to turn left or turn right, as seen in our report's figure. Path 3 can go to path 4, but at the same time it can choose to go at path 5 if a certain condition is met. This is our coding, an example breakdown. Okay, so the algorithm of this coding is firstly find the bottom point by comparing y coordinates of all points. If there are two points with the same y value, the point with the smaller x value will be considered. Okay, if the bottom point is P0 over here, it will be at the first position in the output, and then it will sort this one. It will sort n minus 1 points and sort them by polar angle 2 points. If the 2 points is the same, put the nearest point first. After sorting, over here, after sorting, it will check if 2 or more points have the same angle. If more than 2 points have the same angle, it will remove all the same angle points except for the one furthest from 0. And then it will put M as the new array. Okay, so M as the new array, if M is less than 3, it will return convex hull not possible. Then it will create an empty stack, name S, and then set the push points to S, here, S.0, S.1, and also S.2. Okay, it will then process variance M minus 3. As we can see here, M minus 3 points, one by one. It will keep removing points from stack when orientation of following 3 points is not counterclockwise. It will point next to top in stack, point at the top of the stack, and also point to I over here. Okay, next is move point of I to S. Lastly, it will it will print the contents of S, like over here. So that is how this algorithm is coding, and this is the output. If you can see the output, 0, 3, 4, 4, 3, 1, and 0, 0.
Result.
Vector A and B cross multiplication is like this. The angle between the two vectors is represented by seal. The angle from A to B is anti-clockwise when the cross product is greater than 0, and the angle from A to B is clockwise when the cross product is less than 0. Step 1. Identify the point with the greatest and lowest horizontal ordinate, respectively Qn and Qs. Decide which longitude coordinate point are the maximum QW and maximum QE. Step 2. Join this point to create line QN, QE, QE, QS, QS, QW, and QW, QN. The line then split the scratched point set into many regions. This is 5 cases are present. Step 3. Delete the point in the polygon that are encircled by these 4 vertices. Step 4. Arrange the point in the point set based on the vertex abscissus. The point with relatively big ordinate value are chosen and kept, while the point with relatively small ordinate value are eliminated.
The conclusion of Graham-Scan. Graham-Scan is highly efficient algorithm for finding the convex hull of a set of points in the plane. It relies on sorting points by polar angle and produces a minimal convex polygon. However, it assumes no collinear points, requiring pre-processing for such cases, widely used in computational geometry, computer graphics, GIS, and robotics. Graham scan is simple yet effective. User should be aware of its assumptions and explore alternatives when needed. That's all. Thank you.
Okay, that all from us. Bye. Thank you.